All right, everybody, we're going to get started. We're 5 minutes after. We got a very good crowd here today. This is Chris Neff. I'm a director of sales here at Platform 9. We're joined by Michael Zamora, AJ Zunino, and Michael Riggs, who will be doing the bulk of the content today. Before we jump into that content, I just want to go over a couple things so everybody's clear. I've already put in the chat that all attendees are on mute until the end, where we'll unmute you if there's any questions. The meeting started a little late to allow people to get in the meeting. So first things first, we want to thank you all for joining us today. We appreciate you and your time. So our emails are up there for the presenters. Mine is cneff@platform9, and Mike's is Mike M. Riggs at Platform 9. So please feel free to email us during the session if you need anything. All issues outside of how to, meaning, if you need help figuring something out in terms of how to do something, put it in the chat. But if it's an error that you believe is something wrong or you're doing something wrong to get into the system, just put it into the Slack, platform9users.slack.com. And somebody's manning that today, and we'll be working to get you the answers as soon as possible. We ask you to, if you have time, it's a very short survey. Basically, one question is about what else can we provide in terms of content. And so they're very short questions. And so if you have the time, please fill those out. It really helps us help you. And so if you haven't signed up for the free tier, not everybody has, just feel free to follow along with us and learn. We're going to try to keep it at a pace where the folks that did download or sign up for a free tier will have the opportunity to keep up. But if you didn't, don't worry about it. Just learn today, and hopefully you feel compelled after this session to sign up. So there are 3 levels of license from Platform 9, who I'm going to introduce you to and who you're speaking with today. I just want to level set on all this stuff. The free license tier is what we're using today for the exercise. That's up to 3 clusters and 20 nodes and community support. Growth tier gives you a little bit more flexibility on the license side in terms of growth, a little bit higher level of support. And enterprise is for the customers that need custom solutions for their unique situations. So what I'm going to do now, Mike, move to the next slide. I'm going to introduce you to Platform 9 really quickly, just so you know a little bit about us. We've been around for 7 years. Our goal is to enable freedom in cloud computing. That means all the way out to the edge and in the private cloud as well. We've been doing this, like I said, 7 years. We started based on ex-founders of VMware who founded us and cut our teeth on OpenStack. About 4 years ago, moved into the Kubernetes market, and just recently were named one of Gartner's hottest Kubernetes vendors this year. So that was a nice honor. And so based on our ability to execute, we have regions all over the globe under management. We have over 1 million cores, so we're as big as any major corporation in how we manage. Our funding is the who's who of private equity out there in the market, and our customers are the same. Right, this is a very small representation of our customer base, but just gives you an idea that big customers of different verticals will tend to partner with us. So that's a little bit about Platform 9. Now I'm going to turn it over to Mike, and he's going to tell you a little bit about the product you're working with today or viewing today, and giving you a little background. So thank you very much again, and welcome.
All right. Hey everyone, as mentioned, my name's Mike. I'm Solution Architect here at Platform 9, and we're going to go through a number of things today. I'm going to start off with 1 or 2 slides that just kind of give you guys an idea of what, kind of what it is that we build and how we build it. Then we're going to go through, we'll take a look at the user interface. We'll go through deploying a cluster, a couple of clusters actually. We'll enable some monitoring. We'll go through upgrades. We'll look at what building a CI/CD pipeline looks like, and then we'll talk about some RBOC implementation. So I think overall should be a pretty nice little introduction to Platform 9 and what we do. As Chris already mentioned, if y'all, there's a link to sign up to download our free tier product. So I would encourage y'all to do that. So to start off, the way we architect this is a little bit different than I think some that you'll find. We have over on the left-hand side of my screen, we have a hosted management plane. And so this component we host in our data center, and this has the user interface, and it has some communications components and some authentication components. And then on the right-hand side of my screen, you can think of that as being your environment. This can be AWS, could be Azure, it can be on-prem, bare metal, virtual machines, doesn't really matter. Any of those environments we can deploy to happily. But this is driven by an agent. So we have this agent-based model. The agent gets installed at the operating system layer of your environment. The agent's going to be responsible for a number of things. It's going to be responsible for reporting the resources available to each node back up to this management plane. So it's going to take an inventory of things like storage, compute, network, and then it's going to report that information back up to the management plane that we can then use to go deploy and manage our clusters. The other thing this agent is going to do is it's going to be responsible for monitoring the health of the components in the Kubernetes cluster. And so this is, again, we actively monitor all of our customer environments using this kind of hosted management plane model, allows us to do that. And by doing this, we are typically able to see if there's something going on in a customer environment. We typically are going to see it before they do. It's a very proactive type of experience in that if we see something going on in that environment that shouldn't be, we have some automation, a bunch of automation that's built to help remediate those any issues. If for whatever reason automation can't resolve that, then we'll reach out to you and say, hey guys, there's something going on in this cluster. We're ready to jump on a Zoom or WebEx or whatever that may be and help get that resolved. The kind of key thing to take away here is that this management plane is not a control plane. All the control components, what we typically think of as Kubernetes control plane components, the etcd, API server scheduler, things like that, are still going to reside in your environment. And the only information we carry on this link is just some metadata about the cluster that allows us to do that monitoring and day two operational type stuff like upgrades, security patches, bug fixes. We're going to take care of things like that at the Docker and Kubernetes layer. Okay, so kind of a high level look at what it is that we build. At the end of the day, if you don't take anything else away from the session here today, these are kind of the key features to keep in mind. We're delivering upstream Kubernetes. Again, it's software as a service with a managed services aspect to it, but we're not putting any wrappers around it. We're not changing it in any way. It's just pure upstream Kubernetes. Again, our monitoring technology, we're actively monitoring all of our customer clusters, environments. We're kind of that day two operational arm, if you will, in terms of making sure those clusters are healthy. We have a lot of automation built around, monitoring, maintenance, upgrades, release management. Again, Platform 9 is going to be responsible for keeping those clusters healthy and upgraded. We're going to go through a cluster upgrade here in a couple of minutes. Probably one of the easiest Kubernetes cluster upgrades that you'll see. I talked a little bit earlier about this will run pretty much anywhere. We do have a financially backed SLA, so we do have a 99.95 uptime SLA. We don't care where those clusters are located. They can be in any of those environments that I've already mentioned, and we're going to still be responsible for making sure those clusters stay up and healthy. We are PCI compliant. Then the last one I want to touch on is this next to last bullet point here, is that there's been a couple of vulnerabilities discovered in the Kubernetes layer over the past 3 years. This example is from 2018, but this is an example of kind of by using that remote management plane or that hosted management plane, we are able to patch these types of things up and push them out across our customer base. So this particular example from 2018, we had patched and pushed out across all of our customers in about 3 days. So again, those day two operational type aspects, Platform 9, we've got your back. We have you covered in terms of, making sure those clusters stay healthy and stay online. Okay, so that's just a couple of slides. Let me stop sharing that. Let's take a look at actually deploying a cluster here. Let me get my window open, and let's take a look at that. Okay, so I am going to make this a little bit bigger. There we go. Okay, so the first thing we're going to see here is, and in the interest of time, I'm going to leave, as has already been mentioned, a couple of things real quick. We're going to leave a few minutes at the end of this to answer questions, things like that. So we're going to go through some of these things kind of quickly. We're going to go through deploying a cluster 2 different ways. We'll show you what it looks like on AWS and an on-prem type of environment. So we're going to go through this a little bit quick, but there will be time at the end to answer questions and such. And again, in the interest of time, I'm not going to necessarily go over every aspect of this, but we're happy to dig into more detail afterwards and answer questions as necessary. So the first thing I've got here is, this is my dashboard. This shows me all of my resources wherever they might be. So I've got a couple of clusters here that are these bare OS guys. Basically are either deployed on top of bare metal or on top of virtual machines. And then these 4 clusters down here are all deployed in AWS. We can also deploy to Azure is GA now, and Google Cloud should be, I think, within the next within the next quarter or thereabouts. But the idea here is that I can see all of my clusters no matter where they are. A couple of key things to take away from this are these little green lights over here. So once these clusters are connected and healthy, they are now attached to the Platform 9 management plane. They are now our responsibility in terms of making sure those clusters stay online, that they are security patched, bug fixed, upgrades, all that kind of good stuff. Okay, I'm not going to go into the rest of what's on this screen, just kind of in the interest of time here. But again, there's a lot of information here in terms of features that are enabled, endpoints for cluster endpoints for the API server, IP address ranges, network backends, things like that. But to start, we have 2 different ways to deploy clusters. So we have an on-premise method and a public cloud method. We're going to start with the public cloud one first. We'll go through that entire process so y'all can see what it looks like to deploy in a public cloud, and then we'll go back through it again to see what it looks like to deploy in an on-prem type of environment. And then once we've done that, we'll move on to some of the other topics, upgrades, monitoring, CI/CD, RBAC, things like that. But so to start, let's build a cluster. First one we're going to build is an AWS. So in order to build a cluster in public clouds, the first thing we need to do with our Platform 9 management plane here is tie it to your public cloud account. And so we do that by clicking on this cloud provider button up here, and then this add cloud provider little blue box over here. Now again, right now, AWS and Azure are GA. At some point when GCP becomes GA, there'll be another little box right over here for it. But to configure either one of these, I'm going to select, we'll say AWS for this example, and it's going to want a couple of pieces of information that are proprietary, or not very proprietary, but that are nomenclature for this particular cloud. So for example, in AWS, it's going to want my access key ID and my secret. So I'm going to put those 2 things in here. Azure wants a little bit different information. It's going to want a tenant ID, a client secret, and a subscription ID. But these will all be information that, as long as you've got a subscription to one of those public clouds, you should have that information at hand. So the first thing we do, we create a web provider, or we create a cloud provider. We put in these pieces of information. Once I have done that, they show up in my list of provisioned cloud providers. Once I have added a cloud provider to my management plane, I can then go build clusters in that cloud. Okay, so the first thing we're going to do to create an AWS cluster, I'm going to click this Create Cluster button. I'm going to select where do I want to deploy this cluster. So virtual machines, physical servers, AWS, Azure. For this first go around, we're going to select AWS. And then it's going to tell me I've got a couple of, we have a couple of requirements in terms of your profile for your IAM role that you're using to log in with. We need some basic stuff. We need to be able to manage EC2 instances, volume management, ELBs, things like that. And to be clear, on public clouds, we're not leveraging those proprietary services of these public clouds. So we're not going to be leveraging EKS or AKS or any of those guys. All we're going to do is leverage these cloud providers for the infrastructure components. And what's going to happen is we're going to pull down some vanilla Kubernetes, the Docker runtime, all that kind of good stuff. All we're going to use AWS for in this example is infrastructure. Okay, so we have a one-click cluster setup, which is just going to deploy just a little single node cluster, which should be okay, for dev type purposes, test dev type stuff, but certainly nothing that's going to carry any kind of load or that you're going to want to put in production. So we're going to go through this wizard, this custom cluster setup wizard. We'll give this a name. And then in this example, if I've got, we can provision multiple cloud providers per cloud provider type. And what that means is, say, for example, in my organization, if my test dev team had an AWS account, my production team had an AWS account, maybe my QA team had AWS accounts, I can provision all of those different types of AWS accounts. I can name them, test dev, provisioning, QA, whatever it may be, and then I can select them from this drop down. So in this example, I'm just going to select AWS. Once I've selected AWS, I'm going to grab a region to deploy in. We're going to go with US East. Once I've selected a region, we're going to go ahead and select a couple of availability zones. And then this is what happens when I provision a cloud provider. There is a measure of, there's some discovery that's done in terms of the resources that are available to that IAM role. So in this example here, we're going to see a bunch of SSH keys. These are my fellow SA team folks, but this is discovery. We all have our SSH keys up in AWS. When I configure that cloud provider, these keys get discovered and we can see them right here. So I'm going to select my SSH key. Then we've got a couple of choices to make in terms of clusters. We have a templated model, so I can deploy a small, medium, or large cluster, and we can see kind of what those are comprised of here. But we're going to select custom. And when I select custom, then I've got a couple of choices to make in terms of what OS do I want these clusters to run. These are just the plain images that are put up in Amazon by these respective operating system vendors. So we're nothing proprietary or fancy here. These are just the bare OS AMIs that are put up there by CentOS and Ubuntu. So we'll say I'm going to go with Ubuntu. How big do I want my master to be? We'll go with the T2 large. How many masters do I want? So if I need to deploy a multi-master configuration for production, for example, I'm probably going to want either 3 or 5 masters, depending on the size of my cluster. So to deploy a multi-master cluster, I'm just going to select either 3 or 5. For the purposes of this today, we're just going to go a little single master, so I'm just going to choose 1. And then the same thing here. How big do I want my workers to be? We're going to go with T2 large again, and since this is just going to be a little small cluster, we'll say I'm just going to deploy 3 worker nodes. So I'm going to select 3 here. What Kubernetes version do I want? So we're supporting 117.9 up to 120. I'm going to upgrade this cluster in a couple of minutes. So we're going to go back a revision or 2. Let's say we're going to go with 118. And then we've got some choices to make in terms of Platform 9 can host. If you don't have, some organizations don't have full DNS set up in AWS. We can host the API endpoint using a Platform 9 domain. If you want to do that, we can check this little box here. If you prefer to use your own Route 53, you can do that as well. We've got a couple of choices to make here in terms of in a small little cluster, I may want to run worker processes on my master nodes. If I want to do that, I can check this box. Do I want to run privileged containers? Yes or no? I can check this box. There are reasons why you may or may not want to do so. And then we've got a couple of things here that are this etcd backup. If I check this, we're going to be able to back up our etcd, our key value store. We're going to back it up down this path on the masters. By default, we'll do that every 24 hours, but this will go as granularly as 30 minutes if you're so inclined. And then we can enable, I'm going to uncheck monitoring here. We're going to deploy monitoring separately in a separate little item here in a minute. But if I want to enable monitoring at deploy time, I can check this box. But in the interest of showing y'all kind of what that does, we're gonna do it later on as a separate step. But you can enable monitoring from here as well. The other thing I've got is the autoscaler. This is just a standard Kubernetes autoscaler. Kubernetes can scale up my cluster based on workload. So if I need to do that, we can see here I'm starting off with 3 workers. If I want to enable the autoscaler, I can say, okay, when my workload goes over a certain threshold, let's scale up to a maximum number of 8 workers. So I can enable that right here. We're not going to need that for today, so I'm going to uncheck it, but it's there if you need it. VPCs. So we have a number of options here. I can create a new VPC. I can create a public VPC, meaning that all the components will be out in public IP space. I can create a public and private VPC, which means that the Kubernetes cluster will be in a private subnet, but we'll expose it on a load balancer interface to a public IP subnet. And then you've got the same options. You can create new ones or same options using existing VPCs. Okay, so for the purposes of this, we're just going to go with the easiest option, which is just we'll create a VPC in public. We've got IP blocks here for your containers and services layer. We're going to default to these. You can edit these as necessary, no problem, but these are going to be some defaults. If you need to configure a web proxy to go through for your nodes to have internet access, we can configure that here. And then on the CNI plugin layer, we support Flannel and Calico today. Flannel does not require any configuration. If I use Calico, I've got a couple of choices to make in terms of my IP and IP encapsulation mode, interface detection method, and I may need to change my block size and MTU here. Calico does add an extra layer of headers, so I might need to make some adjustments here just to make sure I don't break my MTU size. But for today, we're going to go with Flannel. We're going to see when we go through an on-prem deployment here in a minute, there are a couple of different options, especially around Calico. I'm going to point those out when we get there, but there are a couple of minor differences in terms of capabilities offered right now in public cloud versus private cloud. We'll see what that looks like, mostly centered around that Calico plugin, but we'll see what that looks like in a minute. And then the last thing here I've got is this is at the Kubernetes layer. Do I want to run default Kubernetes API in groups and versions, or do I want to run all of them in my cluster? So if I want to enable alpha and beta APIs, I can do that here. If I want to pick and choose the Kubernetes APIs that I want enabled in my cluster, I can choose custom here. We're going to go with default for now. If you have, we work with organizations that have, a lot of times if they've got resources out in the public cloud, they may have to, their security team may have to bless those resources. So maybe they've got a hardened AMI that's out there in AWS that they need to use as part of a security requirement to spin up clusters. If that's the case, we can help enable that we can put that custom AMI ID here. And then we will use those. We'll use that AMI to build those clusters with. Okay, so we can put that right here. Last thing I've got, key value pair tags. If I want to identify this as my production cluster for application A, or my test dev cluster in data center B, whatever I want to put there, we can put some key value pair tags there. And then the last thing we're going to get is this summary screen that says, here's everything that we're going to build. And I can take a quick review of this. If I need to change anything, I can go back. But if I like what I've got there, I'm going to click complete. And then what we're doing here is we're just basically leveraging AWS APIs. We're submitting all that information to AWS. And then here in a second, that cluster will start building. Okay. This is this sometimes takes a second or two. Mostly this is because I have a extremely slow internet. I live in a rural area. So sometimes you'll see things here that look like they're taking a minute. 9 times out of 10, that's a result of my painfully slow internet. But we can see here that this cluster is in the creation process. If I come back here to my infrastructure tab, we can see it getting stood up down here. Okay, so that is going to take cluster creation takes, you're going to have some variable time frames there in terms of how many nodes am I consuming, what's my underlying infrastructure. If I'm using very small nodes, it's going to take a little bit more time. If I'm using larger nodes with a lot of CPU and a lot of RAM, that cluster creation process will finish quicker. Okay, so AWS, this guy's creating. We're going to let him go do his thing. Let's talk about then what an on-prem cluster deployment looks like. So the first thing we need to do is we have, and I forgot to mention this earlier, but let me throw this out now. We're driving this through the user interface today because it's it's a nice UI. And we've done a fine job with it, and nobody wants to watch a CLI demo. Nobody wants to watch me type CLI things, but we can do this. We have a Terraform provider for this, so you can do this via Terraform. We have a robust API layer under the hood, so this can all be done programmatically using API calls. We have a scripted tool based on Ansible, so we can onboard nodes and work with nodes using Ansible as well. So you do have options here other than what you're seeing here in the user interface. So I just want to get that out of the way real quick. Okay. So the first thing we're gonna do, so to build a cluster in an on-prem environment, the first thing we need to do is add nodes to our management interface here. So to do that, we click this little onboard node button. We have a 3-step process. We're basically going to download, we're going to run these 3 commands on each node that we want to onboard. The first one's going to download a CLI. The second one's going to generate a configuration for that CLI installer. The third command here is going to prep that node to join the cluster. This third command here is going to do things like we're going to disable swap on the nodes. Kubernetes doesn't really like swap. We're going to set up some IP table rules. We're basically going to configure that node to be part of a Kubernetes cluster. We're also going to pull down the Docker runtime, Kubernetes components. To do this, all you need is a node with a bare OS on it. That's it. We don't need any additional components installed. We're going to install everything necessary for Kubernetes on top of that. So right now we're going to support CentOS 7-ish, 7.4 to about 7.9, I think, somewhere around that neighborhood. Ubuntu 18 and 20, and then Red Hat 7X. So any of those three distributions, we're going to run these 3 commands. That's going to onboard my nodes. Once I have onboarded a node, they're going to show up in this list. And in this list, we can see most of these nodes are already assigned to a cluster, but I've got one, where is it? This guy right here that is not actually doing anything. I'm going to use it to build a little single node cluster. So I have onboarded this node. I did this earlier because it takes a few minutes, but I ran those 3 commands on this node. It's now attached to my management plane. And so now we can go use it to build a small single node cluster. So we're going to go back through the same process, but this is going to be using on-prem resources. And that guy there is a virtual machine running in an OpenStack cluster. So I'm going to say we're going to deploy to a virtual machine. I do have some minimum requirements to meet here: 4 vCPUs, 16 gigs of RAM, 30 gigs of disk. I don't have enough nodes to build a multi-master cluster, but I do have enough nodes to build a single master cluster. So we'll walk through this kind of quick. A lot of this is going to look very similar from what we saw in the AWS deploy, but we're going to give it a name. We're going to select a Kubernetes version. We'll just go with 120. We do have a little bit different stuff to look at here in an on-prem versus public cloud deployment. So in on-prem deployment, I can choose IPv6 if I need to do that. So I can choose my network stack here. We've got the same things about privileged containers, master and worker components on the masters. We've got the same thing about etcd and monitoring, but we've got a couple of additional tools here. So in a public cloud, we're going to, when we go deploy a cluster, we're going to leverage the load balancers that are available to us in that public cloud. So for example, in AWS, we're going to go spin up some ELB instances. In an on-prem environment, if you've got F5s or something similar, they work great. They make a lovely load balancer. But if you don't have anything like that readily available, then we can deploy MetalLB here. MetalLB is a load balancer that's going to run on pods within the cluster. So to enable this load balancer, I'm just going to check this little box, and then it just needs some IP address range for it to serve out of. So if I go enable a service as type load balancer in my on-prem environment, I'm going to need a little IP pool for the load balancer to grab IP addresses out of to expose that service on. So configuration is a piece of cake. I check the box. I give it an IP range down here at the bottom. Okay, we don't need metal LB for this, so we're not gonna deploy that. Monitoring is the same thing as we talked about earlier in the public cloud. In this example, I'll go ahead and leave it checked so we can see what that looks like to deploy it at deploy time. We've got a couple of options here that we don't have yet in public cloud environments. And these are based on, when I mentioned Calico earlier, these are both based on Calico. So we have this network plugin operator. Platform 9 works. We have a number of 5G customers that we're working with, and they had a need for some pretty advanced networking. They had an idea, or they had a desire to, for example, I need my containers to be multi-homed. So I need them to have, I need to have them sitting on multiple IP network segments. So we can do that using a component called Multis. Maybe I need to run MAC VLAN or Open vSwitch in my Kubernetes cluster. We can do that using this plugin operator. We can also enable things like DPDK and SRIOV. So if I need those containers to have direct hardware access for performance reasons, I can enable all those things with this plugin operator. And right now, this is only available on-prem. We don't have that yet in a public cloud. So again, a couple minor differences between public cloud and on-prem. So this is available for on-prem. The other thing we've got here that's kind of new is KubeVirt. KubeVirt, some folks may be familiar with this. It's relatively new in the Kubernetes community in that it allows me to run virtual machines in containers in my Kubernetes cluster. And then I can use my regular Kubernetes tooling to manage those virtual machines and work with them. So if I need to enable that, I can just check this box here to enable KubeVirt in this cluster. KubeVirt relies on this network plugin operator. So if I enable KubeVirt, it's going to enable the plugin operator as well. So those are both available in an on-prem type of environment. All right, same thing with etcd backup. We just skipped on past that. We can do the etcd backup on-prem as well. So the first thing I'm going to do is this is going to be a list of nodes that have been onboarded. I'm going to select, I only have that one node onboarded that we looked at earlier, so I'm going to choose it for my master. If I had additional nodes that were attached as a management plane, I wanted to use them with my workers, I'd be able to select them here. This also, we can sit on this screen for a few minutes. If at this point you want to go then onboard additional nodes using the process we talked about earlier, I can go onboard those additional nodes here, and as I onboard them, they'll start popping up in this little box. So you got a couple options there. I don't have any spare nodes, so we're just going to go with the single node cluster. This is where I'm going to put in my API FQDN. So again, in public cloud, we're going to leverage in AWS, for example, Route 53. In your on-prem environment, you're going to have a DNS entry for your API layer for your cluster. You're just going to put that FQDN here in this little box. Same comment here about container and services for your IP space here. We're going to enable these. You can edit these as necessary. Same comment about the HTTP proxy. If I need to go through a proxy, I can configure that here. We support Flannel and Calico again in the on-prem environment. Again, same idea of like I may need to make some configuration changes. In fact, always and first found, those both work in this environment. But again, the thing here is that in an on-prem environment, if I need to enable the network operator, which we call Luigi, by the way. So if I need to enable Luigi and KubeVirt, both those components rely on Calico. So if I select those up front, I will not be able to select Flannel from here. So they both rely on Calico. So I'm going to choose my my cluster, my network plugin. Same sort of thing as we saw in the public cloud. I can choose my Kubernetes API groups and versions. I can put key value pair tags on this. And I can then, I get that summary here at the end, and then I click complete. And then that's how I deploy an on-prem cluster, okay? I'm not gonna go through this whole entire process because I'm gonna reuse that node here in just a second to show you how we scale an on-prem cluster. But that is kind of a quick walkthrough for deploying both public cloud and on-prem, okay? I'm gonna grab just a quick little drink here. All right, so we can see here then, let me refresh my screen here real quick. So we've gone through a deployment process. We've got a cluster that was in the process of being created. And now this is the one that we created earlier. This is the AWS cluster that we stood up. So from here, well, I'm going to talk about, we're going to move on. We're going to move into some monitoring here for a few minutes. We can see that some of these clusters already have a Grafana link on them. And what that means is that monitoring has been enabled on those clusters. Down here, this guy here that we just deployed does not have that. And so that means that Grafana Prometheus was not deployed as part of this cluster, but we can enable it afterwards. So I can select its radio button out here, and then I can say monitoring. And then what this tells us what we're going to get. And basically what we've got here, what's going to come out of this, and we'll look at it on another cluster, is we're going to install a pre-built, pre-configured instance of Prometheus and Grafana. Prometheus is be configured to send its metrics to Grafana for dashboarding. We've got a number of metrics that we're going to be pre-configured to scrape in the cluster. So we're going to pull some node metrics, some Kubernetes metrics, a bunch of, there's a lot of stuff that happens here. But to enable monitoring, to turn this up, I'm just going to click this little, I click the radio button out next to it, and I click enable. And then monitoring is going to get enabled on that cluster. Now, this is extensible. So when we go deploy Prometheus and Grafana in one of these clusters, it's extensible in the sense that Prometheus has some additional capabilities that we're not leveraging by default. So Prometheus has an export mechanism. So if I want to configure Prometheus to export those metrics to another another system, a dashboarding reporting system, we can do that. If I want to configure Prometheus to enable alerts. So Prometheus has some alerting capabilities. We use it internally to send alerts to our DevOps team using, I think, VictorOps. But it can send emails, it can send webhooks, it can send messages to a Slack channel. But it's all configurable. It's all it's a flexible framework basically that we've enabled here. And then so let's take a look at what one of these look like. So I'm going to select this cluster right here. So when I enable monitoring, this is what we're going to get out of the box. So we've got, this is going to be, I got to get my reading glasses here real quick. So this is going to be metrics on a per host basis. So we see up here, I can select the host that I want to look at. I'm looking at one of my, I think this is in my master, I think. But we can look at CPU utilization, load averages, network traffic, IO. So this is at the host layer. I can see how much memory is available and all that kind of good stuff. But then we've got a number of other dashboards that are built in as well. So say, for example, I want to see what's going on at the Kubernetes layer. So I can select that dashboard, and then I can come over here and I can filter this then by nodes or by namespaces. And then I can see how much capacity or what resources is Kubernetes consuming within my cluster. I can see CPU utilization, memory utilization, and I can see if I've got nodes that are out of disk or misbehaving for whatever reason, and I can see my deployment replicas are all happy, they're all up to date. I've got a bunch of at a glance type information here about my Kubernetes layer. But the nice thing here is that this is to enable this. All I have to do is either I can enable it after the fact, as like we just did, or I can enable that at deploy time, and then that's going to give me all these nice metrics to take a look at. Again, this is an extensible framework. So if I wanted to say, for example, if I wanted to add additional data sources here, I can create new dashboards. I've got another demo cluster running somewhere where we've got Loki that's pulling in some log files. Loki and Grafana play together very, very nicely. I can configure Loki then to point to basically to use Grafana for a dashboard layer. So you can add additional data sources to this. You can create additional dashboards with it. The idea here is it's a pre-configured framework, but then it's flexible enough to where you can extend it and add additional components. You can treat it like just another reporting or dashboarding mechanism that you can then go do stuff with. You can customize as necessary. Okay, so that is a little bit about monitoring. There's a little bit of a difference between, so this monitoring here that we get by enabling this, this allows me on-prem. So that is all driven from pods running within the cluster. What Platform 9 monitors is a little bit different set of information. We are pulling our monitoring data from that Platform 9 agent. So there's a little bit of a gap there. I wouldn't say a gap necessarily, just slightly different things that we monitor versus what is available in an on-prem environment. But again, totally flexible, totally customizable. You can use that as a framework to build out whatever you need. Okay, monitoring. So let's talk about upgrades. So the way Platform 9, the way we do things is so for day 2 operational type things, security patches, bug fix, upgrades, things like that. So as I mentioned earlier, when we looked at that architecture slide, we have this this agent gets deployed. It has a mechanism by which it's it's checking into the back end. It's doing its little phone home heartbeat routine. When we push an upgrade into the back end, that agent gets a notification that there's an upgrade of some sort available. It may be a Kubernetes version upgrade. It may be a minor upgrade. It may be security patch, bug fix, whatever. But that agent's going to get a notification that, hey, there are new components available that can be applied to some of your clusters. And we can see here that, for example, this cluster here is completely up to date. There is no, I don't have anything here that can be updated or upgraded in this cluster, but I've got a couple other ones that have this AWS, this upgrade available. And that's why I deployed this guy here on 118.10, because I wanted to walk through what this upgrade process looks like. So the way this works is, since I deployed this on a lower version, there's automatically going to be some Kubernetes upgrades available. So I can select this cluster, and it says we can go from 118 to 119. And this is what I was saying, probably the easiest Kubernetes upgrade that I'm aware of. Click the little radio button out next to the cluster, click the upgrade button here, and we can upgrade it from here, or we can upgrade it from up here. So either way, I select what I want, and I say, yep, this is what I want to do, and I click confirm. And now that cluster is going to get upgraded. And what we're going to do here is this is a standard Kubernetes rolling upgrade. So for folks that may or may not be familiar with this, I'm gonna and to take you just a little step back. The purpose of this was, some of this is foundational, some of this y'all may already be aware of. Some folks this may be all new to them. So we're kind of starting this with the idea that this may be new to a lot of folks. So for folks that are familiar with this stuff, bear with me here for a minute. But the way this works is we're going to do a standard Kubernetes rolling upgrade, and the way that works is we're not going to have an outage because of it. What happens is it's a rolling process that rolls through the nodes in the cluster. So the first thing that's going to happen is we're going to update the components on one of the nodes. There's a Kubernetes process called drain and cordon, and so we're going to drain the containers off of that node. They're going to be rescheduled to another node. That node gets cordoned, meaning that no new containers can be scheduled on it. Then as that with that node kind of in a temporary out of commission sort of state, then we're going to upgrade the components on that. We remove the cordon from that, pods get rescheduled back onto that node, and then that process is going to flow through the cluster. Okay. So right now, that's kind of how the process works. It's going to, when I do a cluster upgrade, it's just going to do a node by node rolling upgrade of the cluster. What we've got coming here, I think within the next release or two, will be a little different model in that I can say upgrade, say 50% of my nodes at a time. And so it'll basically take down half the cluster, do the rolling upgrade, bring that half cluster up, then do the second half of the cluster. And that can be 50%, it can be 20%, 10%, doesn't matter. But if you've got a really, really large cluster and I'm upgrading single nodes at a time, that can be a little bit of a time-consuming process. So you may want to do larger chunks of that cluster at a whack, so to speak. So that's coming up here in the next build or two. So again, the idea there is to make the upgrade process just as easy as it possibly can be. But then we've got some enhancements coming to that here in the next build or two. Okay, so what I want to do is we've got that's going to cover that covers deployment, both AWS and on-prem. We talked a little bit about monitoring and upgrades. We're going to spend a couple minutes on CI/CD pipeline and RBAC. Get me a little more water here. Before we do that, what I want to do here is I'm going to go maybe about another 5 minutes-ish, and then take a quick little break for maybe 5 minutes, and then we'll jump back into the CI/CD and RBAC pieces afterwards. And then again, want to make sure that we have plenty of time for questions and such after. So real quick, we're going to take a little bit of a slight detour here, and I want to talk about KubeVirt for just a second. So KubeVirt allows me, again, to run and manage virtual machines within Kubernetes cluster. So the traditional model has been, I've got my VMs, I've got them running on top of a piece of hardware somewhere. I'm going to then go stand my Kubernetes cluster up on VMs, running on top of some hardware somewhere. So this kind of flips that upside down in that maybe I want to run, maybe I've got my Kubernetes clusters deployed on bare metal, but I still need to have some VMs running for certain applications. Virtual machines are, Kubernetes is kind of the direction the world is going, but VMs aren't going anywhere anytime soon. They're not going to magically be gone next week or anything like that. There will be a need for virtualized and containerized workloads to happily coexist for the foreseeable future. And towards that, a lot of organizations, VMware is kind of the default sort of virtual machine provider, and nothing against VMware, but they do tend to be a little bit expensive for some organizations, small organizations in particular. And so if I need to run me some virtual machines, but don't necessarily want to incur that VMware tax, or maybe I only have a need for a small number of VMs, KubeVirt is a really, really nice alternative in that I can create my VMs here. I've got new virtual machine. I've got that same sort of wizard stuff that I have that we've already looked at in terms of going through and deploying clusters. I can apply that to VMs. And all the basic functionality is there. KubeVirt is, I've got this little pink little label out here that says early access, or red, pink, whatever you want to call it. It says early access. So KubeVirt is still a very early project in the community. It's not completely full featured yet, but the basic stuff of I want to specify my virtual machine, how big it is in terms of memory, CPU, storage, and I want it to be running Ubuntu 18.04. All that type of stuff. I can declare what my VM is going to look like. I can create storage for it. We can do live virtual machine migration. There's a lot of features and capabilities that are already built into this, even though it's still a fairly immature in terms of Kubernetes projects. But the nice thing here is we've looked at this and we've thought, there's a lot of value in terms of being able to just quickly spin up some VMs right alongside my containers. And so Platform 9 has decided to, we're kind of early adopted KubeVirt. But again, the idea here is I can easily go launch VMs, and I've got full lifecycle management capability over those VMs once they're up and running. So pretty cool feature. It's again relatively new, and it's just going to get better as we go along. One other thing I'm going to touch on here before we take a quick break is monitoring. So we talked a little bit about the monitoring, or this monitoring tab. So we talked about monitoring already in terms of I've got Prometheus, Grafana deployed. They're giving me some metrics and some dashboarding, but I've also got this idea of what's going on at the pod level. I just want some at a glance information in terms of what's going on with just my pod. So here I've got this high level sort of dashboard. I can see all of my clusters in one place. I can see that this cluster here at the top is kind of cranky about something. Then I can see, okay, what's going on? I've got 4 pods that are in a critical state. Here is what's going on with them. Here's the name of the error that's going on. So we got to crash loop back off and We got some pods not ready, so we got some unhappiness going on here in this cluster. And then I've got some pods that are in a warning state. So visibility in terms of what's going on there. We can see this guy here's got a single pod in a warning state, but I've got at a glance information in terms of pod level. Is my stuff happy and healthy? Nope, it's not. I might want to go take a look at these things. We've got alarms here that go along with this as well. And this is a broader sort of view in terms of this is across, all my clusters everywhere. I can filter them by cluster. I can filter them by status. I can filter them by severity. But I can see here that, okay, we've got stuff going on in a number of clusters. Mostly this guy here, test cluster 5, is not a happy lad. But we can see what's going on. Are they critical? Are they warning? What's the issue? What's happening? What's the, what rule is triggering this? So this gives you visibility into what's going on at a pod level in terms of alarms and things that might be going on that you might not. Okay. Now, before I'm going to do one last thing here. So the reason why my TC5 cluster here is complaining is because that node that I walked through the on-prem deployment with earlier, I had detached from this cluster, and now it's complaining because it doesn't have enough capacity to reschedule the rest of those pods. So what I'm going to do real quick is we're going to go ahead and scale this cluster. So this is my on-prem cluster. I'm going to scale workers. I'm going to add a worker to him. Again, these are nodes that I've already onboarded to the management plane. This is the same node that we were looking at earlier. I'm just going to select it. I'm going to say add worker to this cluster. And then now this cluster is going to have additional capacity, and all of those pods that were in various and sundry states of unhappiness, when that node gets reattached to the cluster, those pods will be rescheduled. And then we'll see here in a couple minutes that this cluster is going to be in a much happier state. But kind of the thing to take away from that is scaling clusters on-prem, real easy. Once I've got those nodes onboarded, I go through that little process we just did where I click scale cluster, I add nodes as necessary, scale the cluster, and then we're off. Okay, so I'm going to stop there for just 1 second. It's about 5 till. I think it might make sense to take a quick little break. 2 hours is a fair chunk to sit through at one sitting. So, and I need to go top up my my water here. So let's give it. It's 9. I got 9:57. I'll start back up in just a minute or two after 10, maybe about 5 minutes or so for y'all to take a quick little breather. Then we'll start back. Chris, if you guys want to add anything, feel free.
No, Mike, I think a break is in order and give people a chance to top their coffee off, and we'll see you in 5. Anybody have any questions out there while we're taking a break?
All right. So we'll go ahead and get things going here again. So we're going to take a look at, we're going to go into a little bit more complexity here. I've got, we're going to spend a few minutes talking about RBAC, and then we'll take a look at CI/CD pipeline, kind of what that looks like. But I want to dig into RBAC first. So I'm going to, well, let me reshare this. So we're going to share my whole desktop here. Yeah. And so what I've got, we've got a couple things. So I've got two different users configured. I've got in the background here, I've got my we've got a command line into one cluster. We're going to look at this one in a minute, but this cluster here is a little different guy. So I have two different users configured. I have a, well, we're going to take a step back here for just 1 second before we dig into RBAC. So Platform 9, we have two kind of broad levels of access into the platform. What I'm logged in here is an administrative user. And what that means is that I can create clusters, I can scale clusters, I can create new resources, I can tear clusters down, I can do whatever I want. We also have a self-service user profile that will let you log in to the control panel, to the user interface here, and then be able to consume cluster resources, but not manage them. So those are kind of the two broad levels of access. So I can be an administrator or a self-service user effectively. But then beyond that, we can apply RBAC to further fine-tune those roles. So before I've got an RBAC role configured for this cluster right here, for this on-prem cluster. And we're going to look at what this looks like in a second. So I've got this RBAC tab over here. And then we've got some stuff up here. We've got roles, cluster roles, role bindings, cluster role bindings. And they're a little bit different in that so RBAC role-based access control. So this basically lets me really put some fine-tuned granularity on what a given user level has access to in terms of Kubernetes resources. And so the kind of distinction between the two things here are that a role is used to set permissions within a namespace. So Kubernetes has this idea of namespaces, and that I can have multiple namespaces within a cluster, and that way I can deploy resources under those namespaces, and just makes it a little easier to manage and work with. So Kubernetes components can be either, or Kubernetes objects rather, can be namespaced or not namespaced. There are certain components that live within a namespace. There are other components that are not namespaced components. So a role always you're gonna set permissions within a particular namespace using a role. A cluster role is not namespaced. So an object can be namespaced or not namespaced, but not both. So if you want to define a role within a namespace, you're going to use a role. If you want to define a role that is more cluster-wide and not confined to a namespace, we're going to go with cluster roles. Okay. So what I've configured here is I'm going to select cluster roles, and then we have I'm going to select my that particular cluster. And then there is a role here called, make sure I can, let's see. It is this guy, system public info viewer. Okay. So I'm going to select this role. I'm going to edit it. And what I've changed here is for this API group. So, and what we've got here, I want to go edit for folks that have not had the pleasure of doing this before. And I'm making air quotes with my fingers when I say pleasure, because it's really not much in the way of good time. But what typically happens is I've got a YAML file that specifies my RBAC role, and they're fairly lengthy and they're a little tedious, and it's not much in the way of a good time to go edit that. So towards that, Platform 9 has built this user interface that allows me to select. So I've chosen my role here, which is this public info viewer. And then I'm going to come down here, I'm going to choose my Kubernetes core group. And then within my bindings here, I want to select nodes. And so what I've got then is I've got for this role, I've limited for nodes for the node resource type. this role can only get those types of resources right now. Okay, so I can't do anything but get those types of resources. Now I have a user, cluster role bindings, that I have bound to that role. And we're going to look at that. And it's I have two accounts here. This one here is my admin account. That's what I'm signed as now. My Gmail one is basically just a user. It doesn't have any real administrative capabilities in the platform. So what I've done here is I've assigned my just regular user to this public info viewer role binding. I'm going to come back over to the role. So I bound my user to that role binding. I'm going to come back over here. We're going to filter back down to this guy. And we're going to take a look at it. So, so I've got, let me go back down to where I was. So we're going to go down to 4 and nodes. Okay. So this is the role that user has within the cluster. So it's just a public info viewer role. So for nodes, okay. This guy here, so I am logged on to a node that has access to that cluster. I've got my kubeconfig file here, that's in this directory. We'll take a look at what it looks like. And then we've got we can see here that this is this user here. So this is my non-administrative user, and it is pointed at that test cluster, at that TC5 cluster. Okay. So if I do, so right now, I can't, if I come back to this screen here, list is not something that this user can do. So if I go kube control, get nodes, I get this access is forbidden because my user is not allowed to list resources of nodes in this API group. If I checklist and then update the role, now if I come back over here, same command, now I'm able to get nodes. Super simple demo. But the idea here is that these things get updated in real time, very close to it. And if I want to put really fine-grained roles or really fine-grained permissions on my resources, I can do that. And then there is a command here, and again, apologies for folks that may have already seen this or may be familiar with it, but there's a way where I can say, where I can go verify, like what can I do, what can I not do, what do my permissions look like. So you can say keep control. Let's see here, and this is why nobody wants to watch me type stuff in a CLI demo. Whoops. So the command here is keep control auth can I. Whoops, and create works better if you actually spell it right. Okay, so the command here is keep control auth can I, and then you can put additional, can I do this? Can I do that? Can I create deployments? Can I list secrets? Can I create nodes? Can I list nodes? And so this is how you can then go through. You can figure out, like, do I have this permission within my Kubernetes RBOC? So this is how I can go do that. There is another command. I'd have to go actually look it up. It has been a long time since I've used it, but there is another command where you can create come back here. I can use this screen to either create a new cluster role or edit an existing cluster role. And then once I have done that, I can run a command, and I have to go find it off the top of my head. But basically, I can sort of dry run that RBOC configuration, and it will give me a resultant list of permissions. So if I want to then, before I actually apply that role, or before I actually start assigning folks to that role, I do have some capabilities in terms of, what can this role do? Can I do this? Can I do that? There's also a tool that will let you dry run that RBOC configuration, and it will generate an output that says, here are all the things that role, has available to them. Okay, so this is my this is that user in this particular cluster. That's kind of a quick little peek at RBOC. And again, you know, if I can come over here and, you know, update that role, change it back to where it was. We got a minute or two. We'll do that real quick. Let's see here. Edit. We can put it back. And again, we're going to select our core group and our resource. And then if I uncheck list and we update the role, and then I come back to my CLI here. Back. So we're back to being forbidden. So again, real easy to work with. I can put some real fine-grained, you know, permissions and controls, you know, for any given user or group of users. Pretty easy to work with. Again, if you've ever had the pleasure of doing that sort of thing before. Okay. So RBOC. The last thing here, and this should take too terribly long, is I want to talk a little bit about CI/CD. So I have somewhere in here, very quickly, before we go do this, before we talk about CI/CD, I had this link in the initial slide, in that first slides when we first started talking. We have a demo repo out here. And we can, I'm sure some sort of follow-up, we can send everybody a link to this. But we have a demo repo here. It's Platform 9 community. And this CI/CD demo we're going to walk through is straight out of this little repository right here. But what we've got here in this repo is, you know, initially when we first started off, Chris talked a little bit about our free tier offering. If y'all haven't had a chance to download that and kind of get some hands-on, we would certainly encourage you to do so. But then if you've kind of just getting started and like, okay, I've got this Kubernetes cluster, now what can I do with it? What kind of stuff can we do? This repo has a lot of interesting different projects in it that you can leverage to kind of start getting your feet wet, getting some hands-on sort of thing. So we've got some storage. There's a storage section here. We can go set up things like OpenEBS and Rook and Cinder. So if I want to say I want to see what it looks like to deploy Rook on top of Cinder, we can do that. There's all the manifests are all in here. There's step-by-step configuration, step-by-step information. Okay. So these are available. We've got storage, there's CI/CD, there's a couple of demo applications. We've got some storage plugin. Here's another demo app. We've got some Helm chart. You want to go play with a couple of ingress controllers. I think we've got, Nginx here. So a lot of interesting resources out here in this Platform 9 community GitHub repo. I would encourage y'all to take a look at that. And the one we're going to look at here is straight out of this right here. This is our CI/CD repository. And we have a couple of, we're gonna go for this Jenkins one. And I'm gonna walk through just a little bit of how the configuration, I configured this. This is all built beforehand. Clearly nobody wants to watch me build this. But this is, and again, y'all are welcome to walk through this. It works pretty well out of the box. But basically what we did was, the first thing we did is we labeled a node. So I need to label a node to allow Jenkins to run on. So I can schedule nodes that I want this node to be my Jenkins node. So I'm going to first label that node, telling it that you're going to be my Jenkins node. And what we're going to do here is I actually have Jenkins running in pods in a cluster. So that's the setup here. I need to talk to our documentation guys. This needs to be edited. This repo was originally in a different place. If you try to clone this right here as is, it won't work. But you can just go back to the top level of this and clone the repo from there, and the rest of this will be just fine. And I'll hit up our documentation guys to update this. So what we're going to do, so first thing we do, we label a node. Hey, this is going to be in my Jenkins node. Then we clone the repo. And then within that repo, there's going to be a fistful of YAML files. And they're going to be responsible for doing a number of different things. So the first thing we're going to do is we're going to deploy Jenkins onto that node labeled Jenkins. There's a YAML file that's part of this repository. All we're going to do here is hit it with a little cube control apply, and then that's going to apply that YAML file to my Kubernetes cluster. That's going to then deploy Jenkins. So what happens then after that is this is an AWS, or the cluster that I deployed this on is an AWS, and it's going to expose Jenkins on the load balancer on port 8080. And so if I come back here to my, okay, this is my other test cluster. So we're going to say, we're going to take a look at, yeah. Let's take a look at my services that I've got running in this cluster. Okay. The only service that I've got running right now is that Jenkins instance. And here it's running on this EC2 instance right here on, it's on this and it's on port 8080. And so when I go initially deploy that Jenkins YAML file, this is what I get. I get Jenkins running on a load balancer that's exposed wherever I chosen to expose it on port 8080. Okay. And then if I come over here, and this is it right here. This is my Jenkins. It's running in that. I'm going to come back to this main screen here. So this is that Jenkins pod running. Now I'm logged into it. I configured my little test application. Ran through this last night just to make sure it wasn't going to misbehave. But so here's my test application that I've configured in Jenkins. And what we're going to do here is I'm going to come back to this picture. I skipped part of this, right? So I am not a developer by any means, no way, shape, or form. So I really don't use, GitHub and things like that. But I skipped if we look at this diagram, so you can think of it as this interaction with GitHub is going to be your standard sort of process. You're going to create a branch, you're going to commit your changes, you're going to do the pull request, you're going to do the merge, all that kind of good stuff. We're going to bypass that process. That's standard, GitHub ops, GitOps type of stuff. So we're going to bypass that only because I'm not really a developer guy, and yeah. But you can assume that we've done that. We've created a branch, we've done the make and commit, we've done the pull, we've done the merge pull, and then that gets pushed to my Jenkins executors. Okay, so where we're going to pick up is from Jenkins executors. That's this little window that we just looked at. And so what's going to do is Jenkins is going to do its Jenkins thing. It's going to go through. It's going to it's going to validate. We're going to build we're going to run the application build. Excuse me. I don't have Slack enabled, so we're not going to do that. But then when that application is published, it's going to now we can go completely. Part of this process, we can completely build a cluster, we can spin up clusters, we can tear them down, we can do all this programmatically. For my little example here, all we're going to do is push that application back to my cluster, and then we're going to expose it on on another load balancer. Okay, so but this is the process that's being followed, and again, we're going to skip over this bit. So what we've done then, so I've got my Jenkins is up and running. Jenkins has some configuration required. So basically I just populated it with my Docker Hub and my GitHub credentials. So that's just regular old Jenkins stuff. Basically I connected the Docker Hub registry. This is the app that's built in. It's just a really simple Node.js app. It's nothing fancy, but it's the image and everything's built in. I think it's running on top of an Alpine image or something small like that. So then we configured my pipeline. We've configured a multi-branch pipeline. Basically, what I did then was added the this is again is not correct. I need to update this too. But basically, we just added the repo to it to the source directory down here, to the source file or source destination URL. Yeah, whatever you want to call it. So we added our repo to this. And then we basically pointed it to this Jenkins file that's within the repo. So what we're going to do here is I'm just going to kick this guy out, and let's see here. Oops. Okay. So we see what's going to happen here. It's going to do our and hopefully we can see it's worked the last 2 times I've tried it. So hopefully we'll have a good outcome today. But so what's going to happen in this process is going to take a minute or two. And what's happening is going through the standard sort of process here, standard Jenkins process. We're building it, we're going to publish it. These 2 steps here, we can see take a minute or two, and then we've got a little bit of time in which the application gets deployed back to my cluster. Once we're deployed, then we'll go back. We'll take a look at the CLI. We'll be able to see where that application was exposed on another ELB instance, and then yeah, we'll be able to log on to that application. We can take a look at what it looks like. I think that's the bulk of it. Yeah. So once we run that, we're going to run that process, and then we've gone through this like we've got here, and then this is my sweet application that should be available here shortly. So we can see my deploy process is run. I'm going to come back here to my CLI. Let's get services again. Excuse me. And now we see I've got this React application running exposed as a load balancer. It's on a different ELB instance, and it's on port 80. And typically what happens here, we can see this guy's been up for about 37 seconds. Typically what happens here is there's a minute or two window before DNS resolution actually kicks in, but let's see. Yeah, we'll give it a second. Yeah, and so anyway, so that's a process. So real straightforward. And then from here, if I was again, kind of, you can think of that being part of that CI/CD pipeline process, right? So I may need to make additional changes. I may need to create additional branches. And every iteration, through that pull request and merge process, I can then, update my application. But at the end of updating that application, as soon as I kick it into this Jenkins pipeline, it's going to automatically build my app, push it out to my cluster. I can specify, do I want to push this out into my production cluster, my test dev cluster? If I've got, for example, some Canary environments that are up and running, maybe I want to run a Canary deploy. I can do all those types of things. Let's see here. Okay, we should be, hopefully, again, the slowest thing here is just waiting for DNS to propagate. Come on, man. Let's try a different browser. Oh, laptop. There we go. Okay, let's see if we got that in here. Yay, all right. I love it when stuff works. Okay, so this is, this is again my kind of low budget little React app, but you guys kind of see how the process works in terms of, we got some Jenkins pods running in my cluster. Those pods are configured to talk to both GitHub and Docker Hub. So configured to talk to my, my Docker repository as well as my GitHub repos. And then as I go through my standard deployment process with my standard CI/CD pipeline, all the rest of that can be automated. And for the purposes, for again, in the interest of time today, we didn't go through that in real time, but it's oh look, and now I decided to spring to life in my other browser. Nice. So we didn't go through that in real time, but the other thing you can do is, and I already had those clusters deployed, but you can also do things like, by leveraging Platform 9 API calls, if as part of that process, I want to go spin up a cluster in my on-prem environment or an AWS, maybe for, again, my Canary environment, I can manage those resources. I can turn those resources up and down. I can deploy and destroy entire clusters, all completely programmatic, all completely as part of that CI/CD process. I'm trying to think if there's anything else I want to go through. So again, we'll make sure that y'all have links to this. There's a lot of pretty cool stuff in here. In particular, I think that we've done storage is always a thing. This isn't really part of the agenda, but I want to touch on it for a sec. Storage tends to be sometimes a little tricky, especially the way if you typically you're going to want an additional layer. I can store directly to local disks if I want, but Kubernetes being a cluster type technology, chances are I'm going to want my storage to also be clustered. So I'm going to want something like Ceph or something along those lines. But storage can be a little tricky because not only are you going to have that underlying storage layer, but you're going to want something to manage that storage as far as Kubernetes goes. So towards that, again, in this little repo, we've got Rook. Rook is going to serve as that sort of layer to manage the Kubernetes storage. It provides some additional features and functionality above and beyond storage, but it's going to leverage, say, for example, Cinder under the hood, or OpenEBS, or whatever that may be. So again, a lot of really, really nice stuff in here. A lot of really good tutorials and examples to go through and kind of play with and get your hands wet. Or hands dirty, feet wet, however you want to say it. Looking through my list of stuff, I think that covers the bulk of what I wanted to go through today. It looks like we had a lot of questions and stuff going on in the interim. Very nice. I will stop there. Chris, Jared, AJ, I don't know if you guys wanted to throw anything else out there, but I'll stop there for just a minute. And if anybody else wants to jump in, please do.
No, I think we should open up the mics and see if anybody wants to ask any questions before we tie off.
I think everybody's muted. I'm not.
Yeah, everybody is muted. Is Mike out there? Mike more because I don't have the ability to.
Yeah, I don't know.
If you want to just raise your hand, what I'll do is allow you guys to speak.
Okay, that's the way we do it then. If anybody has any questions, if you raise your hand, we'll unmute you. There's no questions, Mike? We had a bunch of questions during the session.
Yeah, I can see that. That's cool. I like that.
Flying back and forth. So if nobody has any questions, we're going to end a little early today. But please take a couple minutes to fill out the survey as we asked you earlier in the session. Also, if you do require further assistance, or if you'd like us to work one-on-one with you, please do not hesitate to let Mike or me know, and we'll be happy to oblige. So again, thanks a lot for your time today. Unless anybody has anything from Platform 9 or otherwise, I'm going to end the meeting.
Hey, Chris, I just wanted to mention to everyone that you can also visit slack.platform9.io to reach out to us at any time of the day, 24/7. Someone will get back to you within 24 hours there, regardless of whether you're a current customer or not.
Yeah, thanks, Eloy. Appreciate that. All right, everyone. Thanks again.
Yeah, Chris, before you do, I'll echo what Eloy said. So we'll follow up. We'll get everybody out the links that were mentioned in the webinar, as well as the links to the Slack channel so that you guys have access to ask further super technical questions. I know Eloy is a part of that team, as well as a lot of the DevOps architects from Platform 9. So we'll keep the communication going. If there's specific questions that we didn't cover today, we'd be happy to answer those either in Slack or via personal sessions with Mike or one of our other architects.
All right. Appreciate everybody's time. Hope y'all got a little something out of it. And as Jared said, we'll get y'all the links to all those things we talked about.
Bye-bye.
Thanks, guys. Bye.